So tackling matrix multiplication, you'll be happy to hear in a college algebra course, at least my course. I encourage you to use your TI to do this. Later on, we move on to a next class. If you have to do it by hand, then they will teach you that technique then. So first things first, we want to make sure that all of the matrices are entered into the calculator. I think I didn't enter in item C for my previous example, so let's double check. Let's go from there. I'm going to switch over with the TI so you can see. And let's go back and say second x inverse. And I just want you guys to see what the matrices are. Matrix A, we want to verify that's the same matrix that we are using. -4, 10, -12, 5. Let's quit out of that. Let's go to matrix B. I just go to the edit menu just to double check. It is also a 2 by 2. So 3, -8, 9, and 1. We are good to go. And it looks like I don't believe we've entered matrix C. So we're going to go back. I know it has an entry in our calculator, but I don't think it's the same thing. Unless I did this problem earlier with another class, we'll see. But let's go back to our actual matrix C so that we can determine the dimensions. And this matrix, if we want to name the dimensions of this matrix, it is a 2 by 2 rows by 3 columns. So that's a 2 by 3 matrix. And I know if you have your calculator, I'll switch over with you. You can sometimes just guess, is it 2 by 3, 3 by 2, and then the calculator will give you the correct orientation of the matrix and you can compare it to the problem. But it's good to know. So see, actually, we already had it in. It is a 2 by 3 matrix. I'm really interested to see if it's the same numbers that I was dealing with. So remember, if we're going to edit, we have to scroll down to C. And it is a 2 by 3 matrix. I already had it entered in. But if you didn't in your calculator, let's play along. We entered the dimensions 2 by 3. We press enter. And you could say, okay, top row, first column, 2, -3, 4, 1. Press enter, I guess, to get to the next line. 5 and -7. Great. So now let's go back to our home screen. And now we can do matrix math how we'd like. I just forgot what the problem was. So let's double check really quick. And the first thing I'm looking to find is A times C. So let's take a moment to see if we are allowed to, in fact, multiply them. Matrix A has dimensions 2 by 2. So it would be a 2 by 2 that gets multiplied by matrix C, which is a 2 by 3. And you can see right away that we do have the same inner elements of this dimensions. So we will, in fact, get a matrix that is also 2 by 3. We just have to figure out what the result is. So let's go back and see. A times C, let's see how we can recall that up. We're going to say second x inverse, call up the matrix A, that's item number 1, multiplication sign, second x inverse, we're going to have to scroll down to call up item number 3, that's A times C, press enter, and we do have a 2 by 3 matrix. So we can, I can copy the screen over so that we can recopy that over. Sometimes I like to do that for myself. And I'll switch back so you all can see. Let's see if I can plug this in. Okay, so we've got ourselves, if you want to write the answer, it is a 2 by 3 matrix. So we would say 2, -19, 62, 61, negative 86, negative 83. So notice it is more of a complicated process if you tried to do this by hand. It is not necessarily what you think it will be. Adding and subtracting and multiplying by constants worked very nice, but multiplication of matrices is quite different. So let's move on to C times A. This is a really good example to show you that sometimes matrix math doesn't match the arithmetic math that we know and love. We can first see if we do the multiplications, C times A. So let's see, matrix C is a 2 by 3 matrix. Matrix A is a 2 by 2 matrix. And if you guys look at the inner elements, they are not the same. So we already know without any extra work in our TI that it's really not possible. Please don't leave it blank. Please kind of address that you cannot find the answer to this. The number of columns in the first matrix does not match the number of rows in the second matrix. Now, if you forgot our little trick of inspecting the dimensions ahead of time, there's good news if you have your TI. So let me kind of show you that just so that you can kind of double check yourself in both ways. We're going to switch back. A lot of switching today. And let's call up matrix C times matrix A. So what we'll do, favorite new buttons for chapter 7, second X inverse, call up item number 3, that's the name of matrix C. Press the multiplication key one more time, second X inverse, call up matrix A, and press enter and check out what happens. It says error, dimension mismatch, exactly what we were talking about earlier. Sometimes in the newer operating systems, they give you kind of a heads up of what's happening. I remember when I had a TI-83, they kind of, they abbreviate this dimension mismatch thing. So just kind of know if it does give you an error, you in fact cannot do the multiplication. So just kind of wanted to emphasize that so you all were clear on that. So I hope that helps. Let me go back. One more thing. I think there was another part to this problem. We are looking at B square. So we didn't really talk about exponents on matrices, but we do have to remember what it means to be a matrix and what it means to be squared. So matrix B is a 2 by 2. So B square is really the same as B times B. I'll use the asterisk for the multiplication symbol. So if we really want to inspect this and see if it's possible, we have a 2 by 2 matrix multiplied by another 2 by 2 matrix. And then you notice, yeah, we do have the same inner elements of the dimensions. So what happens is our result will be another 2 by 2 matrix. So we'll get that. And then I'll show you that the TI does understand if you wanted to use a dimension of, not dimension, the exponent key, you can do that, or you can simply do B times B. So let's scroll back one last time, or maybe a second to the last time. One more to go. Okay, so we're back to our old screen. Let's move to the home screen. And we want to do B squared. So we're going to call up this B matrix. So second X inverse. And you can call up matrix B, that's item number 2. And you can see, do the exponent key, say B squared, see what happens. We do have a result. But I also want to show you that if for any reason you're not sure if this is working or not, you could also repeat this with matrix B times, just call it up one more time, second X inverse, matrix B, and you'll notice they have the same answers. So let's copy that over just so that we can inspect that. And we will write down the answer as well. It's a little sensitive today, keeps wanting to type in things. There we go. I'll move that up a little bit. So if you guys would humor me a little bit so you can view this, the answer to b squared is actually negative 63, negative 32, 36, and negative 71. So that is it. That's all there is to multiplying matrices, at least in college algebra. Oh, you probably didn't see what I was saying. Got too excited there. So let me see. Let me make sure you see what I see. If you guys notice, all I did was recopy down the answer because I have to address that does have an answer. Negative 63, negative 32, 36, and negative 71. Yes. So that's all there is to multiplying matrices in college algebra. I really encourage you for this section, get really good at editing matrices and calling them up on your TI. It's going to save you a lot of time for the next few sections. So I will see you in the next section when we attack more matrices.